Hey students, it's Mr. D'Amico again with another lesson for you. We're going to be talking about simplifying radicals and the imaginary unit. Okay, so we know that there are certain numbers that are perfect squares. We made a list on our last set of notes. So for example, the square root of 36 is 6. And the square root of 100 is 10. But if you look here, this means the opposite of the square root of 100, so that's why the answer is negative 10. What happens though when the number that we were trying to find the square root of is not a perfect square, for example the square root of 60? What we need to do in this situation is to break up the number into a product of two other numbers. One of them is the square root of a perfect square, and the other one is the square root of a non-perfect square. So if you check that list that you wrote down in your notes, we want the largest factor of 60 that's a perfect square. And the only one that I can see that is a perfect square other than 1 is the number 4. We don't want to really use the number 1 because the square root of 1 is 1, and that doesn't really simplify anything further. So we have the square root of 4 times the square root of 15. Well, we know that the square root of 4 is 2. The square root of 15 does not break down into any other factors that are perfect squares because the only other two factors are 5 and 3. And again, we don't want to use 1. 1 is a factor of every number. It's also a perfect square, but that doesn't help us simplify. So the square root of 15 stays as is. So we have 2 times the square root of 15, or 2 radical 15 as our final answer. What happens if we are trying to simplify negative 4 times the square root of 72? Well, 72 can be broken down into, let's say, the square root of 9 times the square root of 8. Now, there are other choices that are perfect squares of 72, but let's use 9 and 8 because if you don't pick the largest perfect square, we need to keep simplifying. So let's see what happens. The largest the largest factor of 72 that is a square root happens to be 36. So I could have used 36 and 2 instead of 9 and 8, but I chose 9 and 8. So let's see what happens. Okay. The square root of 9 is 3. And I'm actually going to multiply that by negative 4 because that negative 4 was in the original problem. So this is going to give me negative 12 times the square root of 8. However, the square root of 8 is not simplified because 8 can be broken down into 4 times 2. There is a factor of 8 that's a perfect square, and that's 4. So we need to keep simplifying. The square root of 4 is 2. Negative 12 times 2 is negative 24. And this square root of 2 just stays as is because that's not a perfect square. So finally, negative 4 square root of 72 simplifies down to negative 24 times the square root of 2. If I would have picked the largest perfect square, if I would have chosen that one, it would have been the square root of 36. Well, the square root of 36 is 6, and it would have been... Try that again. It would have been 6 times negative 4, which is negative 24, and my leftover still would have been the square root of 2. So it doesn't matter which perfect square you pick as a factor, you just might have to simplify more than once like I had to in this situation. Okay. What happens if we are using the quadratic formula and we have already found the discriminant, which is positive 12, and we're left with a situation like this? So 12 is not a perfect square, so let's simplify that. We can break that down into the square root of 4 times the square root of 3, which is 2 times the square root of 3. So I'm going to replace the square root of 12 with 2 times the square root of 3, and I can still simplify this. Now, if you look closely here, we are adding and subtracting two numbers on the top, and it's all divided by 2. So I'm going to separate that into two separate fractions, both being divided by 2. So we're going to do 20 divided by 2 plus or minus 2 times the square root of 3 divided by 2. And 20 divided by 2 is just 10. And then, if I go back over here, these 2's will cancel. 2 divided by 2 So that just leaves me with the square root of 3. So my final answer is 10 plus or minus the square root of 3. I've just taken this, which was part of the quadratic formula after I found the discriminant, and I kept simplifying. So these would be the two answers to my quadratic equation. Let's try one more. So negative 3 plus or minus the square root of 18 over 3. We can simplify the square root of 18 into the square root of 9 times the square root of 2, which is 3 times the square root of 2. So I'm going to take this 3 times the square root of 2, and I'm going to change that. Negative 9 plus or minus 3 times the square root of 2 over 3. I'm going to separate it now. Negative 9 divided by the square root of 3 plus or minus 3 square root of 2 divided by the square root of 3. Again, why can I do this? Because you have two different terms both being divided by 3. So I can just separate it into two separate fractions and then simplify from there. Negative 9 divided by 3 is negative 3. Then the 3's here will cancel, leaving me with just negative 3 plus or minus the square root of 2. Let's talk about the imaginary unit. Sometimes square roots are negatives, and up until today, we just said that there was no real solution. Well, the imaginary unit is called I, and by definition, I is equal to the square root of negative 1. Again, if you try to do this on your calculator, it would give you an error message. Well, now we know that anytime a radical is negative, in other words, square root of negative 1 and so forth, that equals some form of I. Because anytime there's a negative sign under the square root symbol, there's going to be an I in your answer. Let's take the square root of negative 4, for example. The square root of negative 4 we can think of as breaking it up into just 4 times negative 1, because 4 times negative 1 is negative 4. We know that the square root of we know that the square root of 4 is just 2. And we just learned that the square root of negative 1 is I. So 2 times I is 2I. Therefore, the square root of negative 4 is just 2I. What happens if we had the square root of negative 20? Well, we're going to break this one down. The perfect square root and the non-perfect square root. So like we did earlier, the perfect square root is 4. The non-perfect square root, in this case, wouldn't be 5, it would be negative 5 because it's a negative 20. So the square root of 4 is 2, and then the negative 5 drops down, but we don't leave it like that because we know that we can break down the square root of negative 5 into the square root of negative 1 times the square root of 5. And we know that the square root of negative 1 is I, so this one simplifies to 2I times the square root of 5. Okay, let's say we were doing the quadratic formula and we got something like this again and we had to simplify it. So we're going to take our discriminant, which is negative 28, and we are going to simplify that. Now, with a negative discriminant, remember that means we're going to have no real solutions. We're also going to have two imaginary solutions. So there's going to be two answers to this now that we know how to deal with the imaginary unit I, whereas before we just said there was no solution. Alright, so I'm thinking square root of negative 28 can be broken down into square root of 4 times the square root of negative 7. I know the square root of 4 is 2. Drop down the square root of negative 7. But since that's a negative, we can keep going further with this and make it 2 times the square root of negative 1 times the square root of 7. And we know the square root of negative 1 is I. So that simplifies to 2I square root 7. So now I'm going to take that and replace the square root of negative 28 with 2I times the square root of 7. And then I am going to again break this into two separate fractions because we can do 8 divided by 2 plus or minus all of this divided by 2. And then I'll simplify each fraction on its own. So 8 divided by 2 is just 4. And now the 2's again will cancel, leaving me with just I times the square root of 7. So before we learned about the imaginary unit, again, there was no real solutions, which there still are no real solutions. However, now we can actually see that there are things called imaginary solutions, and we can write these answers as imaginary solutions. 4 plus or minus I times the square root of 7. We also call that a complex solution because there's a real number 4 and an imaginary number I times the square root of 7. All right, let's try another one. Let's put this all together now. Let's actually solve a quadratic, and that should actually say equals 0 after it. So I'm actually going to throw that in there because it's not really a quadratic equation unless you have an equals 0. So now it's a quadratic equation, and we are going to solve. So let us begin. All right, so we are going to use a quadratic formula, and we are going to go opposite of b, plus or minus. So that would be -2 plus or minus the square root of b squared, which is 2 squared, minus 4 times a times c, which is 4 times 1 times 2, all over 2 times a, which is 2 times 1. And then I'm going to take my calculator, and I am going to solve for the discriminant. I'm going to type in exactly what you see here. 2 squared minus 4 times 1 times 2, and that turns out to be -4. And normally we would stop here. We would say there's no real solution, but now we know imaginary numbers, so we're going to continue. So if you recall earlier, we already did this one, the square root of -4. Just in case you don't remember, square root of -4 can be broken down into the square root of 4 times the square root of -1. Square root of 4 is 2, and we know the square root of -1 is just I. So this will be replacing square root of -4 with 2i. And now there's a lot of 2's there, as you can see. I'm going to break that up into 2 separate fractions again. Let's go -2 over 2 plus or minus 2i over 2. And think about what you can simplify here. -2 divided by 2 is -1. And 2 divided by 2 is just 1, so we can say 1i or just I. So we have x equals -1 plus or minus I. That's all that I have for you. I'm hoping you got something out of this in terms of simplifying radicals, because we'll have to do that a lot from now on. Also, the imaginary unit, which we will deal with again from now on pretty often. The next video is actually going to show you some operations with the imaginary unit. For example, I to certain powers, and adding, subtracting, multiplying, and dividing complex numbers. So please watch that one as well when you have time. This will all help prepare you for your quiz and your test coming up next week. Thank you so much for watching, guys. I will see you in class soon. Take care, and keep on solving. Bye, guys.